Section 1.2, explorations with patterns. Math is all about finding patterns. And even at a really young age, that's where we start our kids thinking mathematically, right? We show them shapes and look for the patterns in the shapes. And so that's where we're going to start this semester too, but not with shapes. Okay, so let's look at this example. So I've got 1 plus 0 times 9 equals 1, 2 plus 1 times 9 equals 11, and so on. I'll let you look at the equations here. And we want to look for some patterns. Okay, so you should probably pause the video and try to write down some patterns that you see yourself, and then come back and see what I have. All right, so what do we see as a pattern here? Well, the number that we're adding each time is increasing by 1. So we would expect the next term to be a 6 plus. Now let's see what's happening here. I've got 0, then 1, then 1, 2, 1, 2, 3, 4, 1, 2, 3, 4. Oops, I skipped. 1, 2, 3, 1, 2, 3, 4. So we would expect this one to be 1, 2, 3, 4, 5 multiplied by 9. And what we would expect if the pattern continued, on the right-hand side, the answer is always a bunch of 1s, right? And the number of 1s corresponds to this digit here, right? So 1 plus 0 times 9, I have 1, 1. 2 plus 1 times 9, I have 2 1s, and so on. So I would expect this to be 1, 1, 1, 1, 1, 1. 6 1s here. All right, and so the question is this a pattern that continues or not? So what do you think? Well, it does seem to continue for a while, but actually it does not continue in general. So here's an example where the pattern breaks down. So we've moved all the way up to 13, and so now I have 13 here. These digits need to be 1 through 12, and then multiplied by 9. And you can see here, it looks like it's starting to carry the pattern, but then we've got some 0s and 9s and 2s in here, and so that's a problem. So the pattern didn't continue, and what broke it down was the fact here we've got 2-digit numbers. Okay, so when we're looking for patterns, we have to be careful, right? We need to either show that the pattern does continue infinitely, or we find a counterexample to the pattern. In this case, we have a counterexample where the pattern stops working. All right. Okay, so we want to use something called inductive reasoning. We're going to make generalizations based on observations and patterns. This might lead us to a conjecture, which is a statement that's thought to be true but hasn't been proven. We can prove that the conjecture is false with a counterexample. That's what we did in the last example. A counterexample is just a statement that contradicts the conjecture. Okay, so let's look at another example where making a conjecture is a little dicey. So here, the idea is I want to choose points on a circle and draw a line to connect those points. And we want to count the number of distinct regions created by those lines in the circle. So you can see in these pictures here, when I have 2 points, I get 2 regions. When I have 3 points, I get 4 regions. When I have 4 points, I get 8 regions. So again, I'm looking for some pattern to help me get an idea of what's happening here. So I want you to think for a second if you can recognize a pattern, and then I'll tell you what I see. All right, well, let's look at the number of regions here. I've got 2, then 4, then 8. These number of regions are going up by a factor of 2 every time. So I would expect that if I had 5 points, oops, I can't spell. If I had 5 points, I might expect there to be 16 regions. So if this is the pattern, what would you expect for 10 points? Well, let's write these a little differently. So I have 2. This is 2 squared. This is 2 cubed. This is 2 to the 4th. And so you can see that the exponent on 2 is just 1 less than the number of points. So our guess or our conjecture is that for 10 points, I'm going to have 2 to the 9 regions if this pattern continues. Well, let's see. All right, so like we said, if we're going to move on to 5 points, we'd have 16 regions. And so our guess would be 512 regions for 10 points. So the first check would be to see, well, does it work for 5 points? So here's the circle with 5 points, and you can see all the regions. And in fact, we do get 16. And so let's move on to 6 points. Here's all the regions that you find with 6 points. For 6 points, our guess would be that it would be 2 to the 5th, right, which is 32. And in fact, in this circle, there are only 31 regions. So our conjecture failed. In this case, we can't say that the pattern is going to continue. So to figure out what's going to happen with 10 points, we would have to actually do the circle with 10 points. I'm not going to do that because that's going to get really messy. Okay. All right, so what is a sequence? A sequence is an ordered arrangement of numbers, figures, or objects. We can classify them by their properties. We're going to call the terms of the sequence A sub 1, A sub 2, A sub 3. Notice that this is a subscript, not a superscript, so it should go below the A, not above. Okay. And that's just going to tell me the terms of my sequence. So here's a sequence, 1, 2, 3, 4. In this sequence, A1 is the first term, and that's 1. A2 is the second term, that's 2. A3 is 3. And A4 is 4. You could guess, based on the pattern, what's going to keep happening. So what would A5 be? It should be 5. And in general, AN, the nth term, is just going to be n. Oops, I'm in the way here. Let me erase. All right, so what about the pattern with the dice? So here, I've got a die with 1, a die with 2, a die with 3. Then we circle back to 1, 2, 3, 1. So you would expect the next die to be 2, 3, and so on. 4, 7, 10, 13, 16. What's the pattern here? Well, if you look closely at these numbers, they're all increasing by 3, right? So I would expect the next number to be 16 plus 3, which is 19, and then add 3 to that to get the next number, and so on. This is a special kind of sequence, and we're going to talk about this in more detail in just a little bit. How about 4, 12, 36, 108, and so on? So again, I'm looking for the pattern. If you look from one term to the next term, we're multiplying now by 3. So this sequence is found by taking the previous term and multiplying by 3. And again, this is a special kind of sequence we're going to talk about in just a minute.